All right, class, welcome back. Can everybody hear me okay?
Hey, everybody, I hear you.
All right, rock and roll. All right, let's look at this exam number 24 here. All right, Tim Duncan of the San Antonio Spurs once scored 36 points on 22 shots in an NBA game, shooting only 2 points and free throws worth 1 point. How many of each type of shot did he make? Well, based on the question here, we should make our variables the number of each type of shot. So let's let T be the number of 2-pointers. And let's let F be the number of free throws. So it says he scored 36 points on 22 shots. Okay, so in the game, let's see, if they scored a total of 36 points, then we should take 2 times the number of 2-pointers and then 1 times the number of free throws. That should give us a total of 36 points. And it says 22 shots. Move this one down. So the number of 2-pointers plus the number of free throws should be 22 total shots. So there's our two equations. The first one tells us we can rewrite T as a 22 minus F. So if we, let's see, now let's do the other way around. F is 22 minus T. This makes it easier to substitute it into this next equation. So we have a 2T plus F, and F is 22 minus T. And now we can solve for T. So 2T minus T is a 1T. 36 minus 22 is 8 and 6, which is 14. So if we replace T here with 14, we get 8 for F. And of course, we could check our work. So the first one says T plus F. That's 14 plus 8 equals 22. So that one works out. And then the second equation, 2T, 2 times 14 plus F, which is 8. This is 28 and 8, which would be 36, which is our right-hand side. So we know we got it right. Any questions? All right, let's look at this pigs and chickens here. There's 7 more pigs than chickens, with a total of 58 feet. How many of each type of animal are there? Based on the question, we should let P be the number of pigs, C be the number of chickens. So there's 7 more pigs than chickens. So if we take the number of chickens and add 7, we get the number of pigs. Now feet, there's 58 feet. Pigs have 4 feet, chickens have 2 feet. So if we take 4 times the number of pigs, 2 times the number of chickens, we should get a total of 58 feet. So there's our 2 equations. So the first one says P is C plus 7, so we can just substitute that right in. C plus 7. So solving for C, we have a 4C plus 28 plus 2C. It's 58. So 6C is 58 minus 28 is 30. So C should be 5. If we plug that in up here, 5 plus 7 is 12 pigs. Let's check our work. First equation, C plus 7, that's 5 plus 7 equals 12, which is the number of pigs. So the first one works out. The second equation, P is 12, C is 5. So what is this? This is 48 plus 10, which is 58, which is the right-hand side of the equation. Any questions? All right, so that's our last daily exam for the semester. This will be our last quiz. Let's see, it's 306. Let's take 15. So it'll be what, 321. Let's get your breakout rooms going.
So this will be the last one, sir?
Yeah, because we've covered all the material in the textbook. From here on out, we're just going to be working all the homework problems.
Oh, okay, cool.
And to prepare for the final. So breakout rooms ought to work. All right, class, welcome back. Let's check out this quiz here. The landscaper is designing a park and placed 2 orders with the nursery. First order was for 13 trees and 4 bushes and totaled $1,075. The second order was for 6 trees and 2 bushes and totaled $500. What is the cost of 1 tree? What is the cost of 1 bush? Well, let's let T be the price of a tree and B the price of a bush. So we had 13 trees and 4 bushes. The total was $1,075. The second order was for 6 trees and 2 bushes. The total is $500. We have 2 equations and 2 unknowns. Let's see what we can do here. Let's solve for B. We got 1075 minus 13t. That's what 4b is. So B is 1075 minus 13t divided by 4. So if we substitute that in here, we get 6t plus 2 times this is equal to 500. All right. So 2 over 4 here. That gives us this guy over 2. If we simplify that. So now, actually, let me move this over here. Give me some space here. To get rid of this thing here, I'm just going to multiply everything by 2. So we got a 6t plus 1075 minus 30. No, multiplying everything by 2. So I need a 12t. That equals 1,000. So, and I lost my t here. 12t minus 13t is a negative t. And 1,000 minus 1075 is negative 75. So that tells us that t is 75. So if we plug that in up here, 1075 minus 13 times 70. I'm running out of room here. I'm just going to take this. Move it down here. There. 13 times 75 divided by 4. All right, what is this? We have calculator here. 13 times 75, 975. So 1075 minus 975 is 100 divided by 4 is 25. So we have 75 and 25. And of course, we can check our work if we want to. All right, number 2, a test has 20 questions worth 100 points. There's true, false questions worth 3 points each and multiple choice questions that are worth 11 points each. How many true, false questions are there? So let's let our, our symbol for both true and false be the number of true, false questions. And we'll use M to be the number of multiple choice questions. All right, so there's 20 questions total. So the number of true, false plus the number of multiple choice would give us 20. And there's 100 points. So true, false are worth 3 points. So 3 times the number of true, false, and then multiple choice are worth 11. And we should have a total of 100 points. So there's our 2 equations. Let's see, we could replace M with a 20 minus F. So if we substitute that in, I said F, it's more like a T, right? That's 11 times 20 minus equals 100. So solving for true, false here, we have 3F. See, 200 times 11 is 220. Minus 11 true, falses should give us 100. All right, so 3F minus 11F would be a negative 8 true, falses. This would give us a negative 120. So the number of true, falses, 120 divided by 8, just 15. Since we know that, we can substitute it in right here, and we get 5 for M. Try that 5 again. There, a little better. Any questions? All right. So let's get our book here. Appendix. Let's get rid of the tools pane. All right, so we're going to start working the homework problems to prepare for the final. So for page 213, determine the size of the matrix. Well, that's going to be rows by columns. So 1, 2, 3, 4 rows, 2 columns, a 4 by 2 matrix. All right, solve using any method we want. Let's look at number 2 here. So if we're going to solve this, we can do substitution since we're used to that. Let's see, 2x is 24 minus 3y. So x is 24 minus 3y over 2. We substitute that in here. We have an equation with nothing but y in it. Let's get rid of this 2 here. So let's just multiply everything by 2 to get rid of that. Let's see, 128. All right, I don't know what 7 times 24 is. Hold on. 7 times 24 is 168 minus 21y plus 16y is 128. So this gives us negative 5y is a negative 40. So y is going to be 8. We plug that in up here. 8 times 3 is 24. So this is 0. This is our x. All right, and we can always plug the numbers in and check our work. Let's get the next one. Number 3. Okay. I don't like all these fractions. I'm going to multiply here everything by 6. So we get a y equals 3x plus 2. I like that one better. And now we can substitute y straight into this guy here. So we get an x minus 1/3 into 3x plus 2 equals negative 1. And let's just multiply everything by 3 to get rid of those fractions. So we get a 3x minus 3x minus 2 equals negative 3. So what does this mean here? Negative 2 equals negative 3. The x has just totally disappeared. All right, what this means is there is no solution, right? Remember, if you think of these as lines, see right here, this line has a slope of 3, right? If we put this one into slope intercept form, let's see, we have y equals, multiplying everything by a negative 3, 3x plus 3. The slope here is also 3. Both lines have a slope of 3. That means they are parallel. If you look at them, this one is at 2. Looks like that. This one, its intercept is at 3. Looks like that. These are parallel lines. They never cross, so there is no solution. Does that make sense?
Yeah, somewhat.
All right. Well, when you get negative 2 equals negative 3, that simply isn't true. So there's no solutions here. And that's what it looks like when that happens. All right, let's look at number 4. All right, this one, again, let's get rid of these fractions. So 6/2 is 3, 6/3 is 2. I like that better. Let's solve for y here. 2y is 24 minus 3x. So y is 24 minus 3x divided by 2. So over here we have a 3x over 4 plus 5 times y, which is this, equals 33. Now we have all these over 4s and over 2s. Let's just multiply everything by 4 here. So we get a 3x plus 10 times a 24 minus 3x. And 4 times 33, 132. All right, so 3x plus 240 minus 30x is 132. So negative 27x is negative 108. So x is 108 divided by 27, which is 4. If we substitute that in here, we'll take this. And 24 minus 3 times 4 over 2. 24 minus 12 is 12 over 2 is 6. So there's our x and our y. So yeah, these, if you treated them as lines and graphed them, they would cross at 4, 6. Let's work another one here. No fractions. Let's just solve for x this time. -8 plus 3y. So x is -8 plus 3y over 2. We substitute that in, we have 3. -8 plus 3y over 2 plus 5y equals 7. Let's get rid of this over 2 thing by multiplying everything by 2. So we got 3 times -8 plus 3y plus 10y equals 14. So -24 plus 9y plus 10y equals 14. So 19y equals, let's see, 24 and 14, that's 38. So y equals 38 over 19. If I did this right, that's an ugly number, right? Let's plug it in and see what we get for x. This would be -8 plus 3 times 38 over 19 divided by 2. So let's see, since it's over 19 here, 8 times 19. 8 would be 152 over 19. And now 3 times 38, 114 over 19, all over 2. So 114 minus 152. This gives us a -38 over 19 divided by 2. 19 times 2 is 38. So this is -38 over 38, which is a -1. So we can check our work. You get a funky number like that, it's a really good sign to check your work. So the first one, left-hand side, is 2 times -1 minus 3 times 38 over 19. So what is this going to be? This is, all right, so since we have a 19 on the bottom, this -2 here would be a -38 over 19. That's -2. And then minus 3 times 38. 3 times 38 is 114 over 19. So 114 and 38 is 152 over 19, which is 8. It's a -8, which is the right-hand side. The first equation worked out. Let's check the second one here. Left-hand side, 3 times x plus 5 times y. All right, again, we have this 19 on the bottom. So 3 times 19 is 57. This is a -57 over 19 plus 5 times a 38, which is 190 over 19. So 190 minus 57 is 133 over 19, which is 7, which is the right-hand side. So 38 over 19 is an ugly number, but it happens to be the right number. And number 6. All right, we have a bunch of fractions here. Let's get rid of them. Multiply everything here by 4. So this will give us a 2x plus y equals 6. This one, let's multiply everything by 15. 15 over 5 is a 3. 15 over 15 is 1. 15 over 3 is 5. I like these two equations better than those original ones. So let's take this one and solve for y. 6 minus 2x. Substitute it into here. So we have 3x plus 6 minus 2x is 5. 3x minus 2x is x. 5 minus 6 is a negative 1. Plug that in up here. 6 plus 2 would be 8. So it's happened to be the shortest one yet, huh? Even though there's all these ugly fractions, it looked like it was going to be a lot of work. All right, number 7. All right, no fractions. This one says x is negative 25 plus 4y. Let's substitute that in. And now solve for y. So we get 16y equals negative 15, or y equals negative 15 over 16. If we plug that in over here, let's see, we're going to have a 6, well, let's see, negative 25 plus, that's going to be negative, minus 4 times 15 over 16. This is negative 25 minus 15 over 4. 16 is 4 by 4. So a negative 25 is a negative 100 over 4 minus 15 over, what did I get, an 8? 4 gives us negative 115 over 4. Which is an ugly number. I don't think that's right. I think I did something wrong here. But let's find out. Let's check and see. I don't remember getting that number. So the first one we have left-hand side is x minus 4 times y. So it's going to be a plus. This is going to be 15 over 4. So that gives us 100 over 4, which is 25. Oh, this is a negative, which is the right-hand side. So the first equation works. Let's check the second one. So we have x plus 12 times y. All right, let's see what we can get here. 12 is 3 times 4, right? And 16 is 4 times 4. So we got negative 115, and then 15 times 3 is 45. This is all over 4. So 115 and 45, negative 160 over 4, which is 40. It's supposed to be 10. So I did something wrong here. So what I'm going to do is wrong. Let's do it again. See if we can get it right. Okay, so let's solve for x. X is negative 25 plus 4y. Substitute that in here. Negative 25 plus 4y plus 12y equals 10. So 16y equals negative 15. So y is negative 15/16. That's what we got last time, right? All right, let's see if we get something different for our x now. Actually, negative 25 plus 4 times negative 15/16. So this is negative 25 minus 15 over 4. This is 25 is 100 over 4. So this is negative 215 over 4. Last time I had negative 115 over 4. Yeah, where did I get that? That's not right. So I got the same answers here that I got up here, but we checked them and they were wrong. So maybe I did something in my check here. Let's redo this and see if I did something wrong in my check on the second equation. So we got negative 115 over 4 for our x, and then 12 times y, and y is negative 15/16. See, 12 is 3 times 4. And 16 is 4 times 4. So we got negative 115. 15 times 3 is 45. Right? All over 4. 115 and 45 is 160 divided by 4, which is 40. Okay, which is not 10. So in order to try this again and not get the same results, instead of solving for x like we did up here, the first step, we found x in terms of y. To make sure I root out whichever brain fart I am making, instead I'm going to solve for y in terms of x. So y is 25 plus x over 4. Now I'm going to substitute that in to the second equation. X plus 12 times y. All right, to get rid of this over 4, I'll multiply everything by 4. So I got 4x plus 12, 25 plus x equals 40. And multiplying the 12 through, let's see here, 12 times 25 is 300. That's 12x is 40. So I'm getting 16x equals negative 260. So x is negative 260 over 16. 260 divided by 16 All right, it's going to be a fraction. So let's see here. 260 divided by 2 is 130. 130 divided by 2 is 65. Divide that by 5 is 13. 16 is 2 times 8, which is 2. So that's 4. So 2 times 2 times 4. So that I can do this. Now 5 times 13 is 65 fourths. That's not what we got before, right? We got 115 over 4. I'm getting negative 65 over 4. So let's plug that in up here and see what we get. 25 minus 65 over 4 divided by 4. So 25 is 100. So 100 minus 65 is 35 over 4 over 4. So that's 35 over 16. So let's check our work. So the first equation says x minus 4 times y. All right, this is 35 fourths. So this is negative 100 fourths, which is negative 25. That's the right-hand side. Now let's look at the second one. So we need an x plus 12 times y. All right. So 12 is 3 times 4. 16 is 4 times 4. 35 times 3 is 105. 105 minus 65 is 40 over 4, which is 10, which is the right-hand side. Boom. Finally. So that's how you figure it out whenever you're having problems, right? We did 3 attempts here. The first one was so close, right? It petered out on the second equation we checked. So I tried it again, but I took the same path. And whatever path I was taking, it led me to make the same mistake that I made the previous time. So to get around that, I took a different path. Instead of starting off solving for x, I solved for y first to help me avoid whatever brain fart I was making in my arithmetic. And it worked out. So it's a trick in problem solving. All right, sometimes when you don't get it right, that's when you learn the most. All right, number 8. All right, no fractions. Let's solve for x over 9 minus 6y. Substitute that in here. All right, negative 6 plus 2 is a negative 4. And negative 3 minus 9 is a negative 12. So y here is 3. Plug that in up here. 9 minus 6 times 3. 9 minus 18 is a negative 9. So that's x. All right, folks, let's take a 15-minute break. I'll come back at 10 past 4. All right, class, welcome back. Let's look at number 9.
So
Hello. Oh, Scam Likely is calling. Not today, Scam Likely. All right, this second equation already has y in terms of x. Let's just substitute it in right here.
I've been trying to reach you about your car insurance.
Yeah. All right, substituting that in, we get, I'm just gonna keep going over here. We get an 8x plus 15x minus 9 is 24. So 23x equals 24 minus 9 is 15. So x is 15/23. Substitute that in over here. We have 5 times 15/23 minus 3. Let's see. Where's my calculator? 5 times 15 is 75. And then 3 times 23 is 69/23. So 75 minus 69 is 6/23. And you can check. And hopefully we did it right. All right, page 214. I know we've done number 10. We just did number 11. We've done 12. I remember 13. And we've done 14. We've done 15. We've done 16. And we've done 17. We've done all of those problems already. So let's go back in time. To homework on page 199. All right, if we're going to solve for this, since there's two ways of solving this one, because the x is in the exponent and it's a 10, we can take log base 10 of both sides. Right, so that goes away and x is log base 10 of 34,926. They want an exact answer, so that's it. Or because the x is in the exponent, we could use any log we want. Let's say we took the natural log and we used our other trick where you could take the exponent and put it out front. We get x, natural log of 10, natural log 34,926. So x is this guy divided by this guy. Two totally different looking answers, but they happen to be exactly the same. Okay. So depending on how you do it, your answer is going to look different sometimes. Now for number 2, let's just natural log both sides. Because natural log and e to the x undo one another. So we have natural log of 64. I mean, we could take a log base 10, you know, and that would just be weird, right? If we took log base 10 of e to the x, we could do that. We could take this and move it out here, and we would get x is log base 10 of 64 over log base 10 of e. But which one of these answers looks prettier? This one, right? Well, let's see. X is 3 to the 7th. Well, that's my answer. That's how I would do that one. Or we could plug in 3 to the 7th power and say x is 2,187. All right. Honestly, I like 3 to the 7th better than the number 2,187. All right, this one over here, number 4, 2 ways of doing this. We might recognize that 4 and 1024 are both powers of 2. This would be 2 to the 2x because 2 squared is 4. And 1024 is 2 times 2 is 4. 2 is 8, 16, 32, 64, 128, 256, 512, 1028, 2 to the 10th. All right. So because these are both 2 to the power of, we can just say 2x equals 10 or x equals 5. One way of doing it. Or let's say we took natural log of both sides. This would come out here. So we have x natural log of 4 equals natural log of 1024. So x is natural log of 1024 over the natural log of 4. You could do it like that, but watch this. If we kept going, 1024 is 2 to the 10th. 4 is 2 squared. This says we can pull a 10 out front. So we have 10 natural log of 2. This says we can pull a 2 out, 2 natural log of 2. Natural log of 2 over natural log of 2. 10 over 2 is 5. Same answer, different path. All right, you might be tempted to leave it like this. Well, technically that's right, but it's not simplified, you know? So anytime you see something with these big numbers and you can do it like this, that's the method you're going to want to take so that you get the pretty answer as quickly as possible. All right, number 5. Since the variable is inside the log, let's isolate the log first. 9 divided by 3 is 3. Now to get that out of the log, let's do e to the both sides. So 5x is e cubed, or x is e cubed over 5. That's the exact answer. Here the x is in the exponential, so let's isolate the exponential. We add 7 to both sides. We get this. The natural log, both sides of this guy. So we get 4x minus 5 equals natural log of 11,250. So copy, paste, add 5, divide by 4. There's our exact answer. All right, let's look at this one. All right, this one, let's do natural log of both sides again. So we get 1 minus 8x is natural log of 7957. So x is natural log of 7957. We're going to have to subtract 1 and divide by a -8. Over here, let's isolate our exponential. 73 over 4. Now we'll take the natural log of both sides. So we have 7x is natural log of this. So now divide by 7. All right. Boom. Exact answers. All right, number 9 and 10. Here's another one where these are both powers of 3. So 9 is 3 squared, 27 is 3 cubed. So 2x is 3. So x is 3 halves. Same thing over here. 25 is 5 to the -3. So 2 minus x. 2 minus x is a -3. So x is 5. Moving on. There's plenty of them here, aren't there? All right. All right, this was just like the last one. 27 is 3 cubed. So 1 minus x is -3. So x is 4. This one, the variable is an exponential, so let's isolate it. 250 divided by 50 is 5. Now we can natural log both sides. We got a 0.06. T is the natural log of 5. So T is natural log of 5 over 0.06. These look like the ones that show up in those exponential decay problems. So this one's just like the last one. Let's isolate the exponential here. Natural log everything. So we have, all right, is 7k equals natural log of 1/2. So k is natural log of 1/2 divided by 7. This one's just like the last one. Natural log of 10,000 k is natural log of 1/2. So k is natural log of 1/2 divided by 10,000. All right, let's simplify this. Here's our variable, right? Well, 1,000 divided by 500 is 2. 1 plus 0.01 is 1.01. All right, because this base is just some random number, we can use any log we want. I'll use natural log, because now we could take that and put it over here. So we have T times the natural log of 1.01 equals natural log of 2, where T is the natural log of 2 over natural log of 1.01. So that's one way to do it. All right, over here, when they say log, they mean log base 10. So let's do 10 to the power of both sides. So we get a 4x equals 100, or x equals 25. All right, let's see, let's isolate our exponential. 20 divided by 5 is 4, all right, which is 2 squared. So 3x has to equal 2, where x is 2/3. This one over here, the 4 and the 6, they aren't both powers of 2. So we can't do this trick, but we can do the other one where we just take log of anything any log we want of both sides. So this comes out. So we have 3x natural log of 4 equals natural log of 6. So x is the natural log of 6 over the natural log of 4 and a 3 down there. There's other tricks with logs that we didn't learn about. Here's what they are. Log of a minus b is log of a divided by log of b. Similarly, this would be log of a times log of b. They didn't tell you this, but you could do that. So this would be 1/3 natural log of 2. But you don't have to do that because they didn't put these little tricks in the book. Lots of things you can do with logs. Build a cabin. All right, log base 10. So let's do 10 to the power both sides. That goes away. We have 100 here. So 2x is 95. So x is 95 over 2. Same trick over here. 5x equals 1,000. So x here is 200. All right. Page 200. Looks interesting. All right, if our money grew to 12,000, so that's the amount it grew to, as simple interest on an investment of 10,000 in 5 years, what is the rate of interest? All right, so simple interest is where you wait till the end of the whole thing and then collect interest once. So you have your principal plus your interest. Your interest, IPRT, I par T. So we could write this as a 1 plus RT. That's our amount, right? Using that, we want R. So let's solve for R. So let's see, RT is A over P minus 1. So R is 1 over T and A over P minus 1. So T here is 5 years with 12,000 over 10,000 minus 1. So let's see, what is this? 12 divided by 10 is 1.2 minus 1 is 0.2 and divided by 5 is a 0.04 or 4%. Number 22. How long would it take your brand new car to depreciate 40%? Assuming that it depreciates at a 15% per year, compounded continuously. So a hint here, if you lost 40%, what would A be? A would be 60% of its original value. So compounding continuously, right? It depreciates at 15%. So that means R is negative 0.15. All right. What were they asking? How long? So we need to solve for T. I think we've done this enough times where you know that if you do that, you get this by taking natural log of both sides of that equation, right? We've done that a million times. So negative 0.15 natural log. If A is 0.6p, notice that the p's go away. That's why it doesn't matter how much it was. This is how that number falls out. The p disappears. So if 0.6, take the natural log, divide by 0.15, and we get 3.4 years. All right, this one is a plug and chug. All right, so here's our population P in terms of time. So for A here, the year 2000, that would since 1990, that mean T is 10. So P of 10 is 2,500 e to the 0.0293 times 10. So let's do this. 0.0293 times 10. E to the times 2,500. And we get 3,351.12. All right. I guess we should just round to the nearest person, right? Boom. And the others, it's the same thing. Just replace T here with 20. And here, 2018, that would be your what, 38? 28, 30, 20. 28. So you just plug in those numbers for T. Okay. The population of a city in 2000 was 240,000 and exponential growth rate was 1.2%. So R is 0.012. Write the exponential growth function. Populations grow continuously. Specifically, we use this for our P. E. So that's our exponential growth function. When will the population be 2,700? So when will it be this amount? Well, we're solving for when. So if you solve for T here, you all should know by now that it is this by taking natural log of both sides of that equation. So we got 1 over 0.012 natural log 275,000 over 240,360. If we plug this in, 275,000 divided by 240,360. Take a natural log, divide by 0.012. Gives me 11.23. So that's years. So if 2000 is year 0, 11 years later, that'd be 2011. All right, some bacteria growing. Let's see what we can do with this. N is the number of bacteria in thousands. T is the time in minutes. If the bacteria is 570,000, that means N is 570. And T is 4. Find the value for K. So if we have N equals e to the KT, we'll natural log both sides, right? So we get a KT is natural log of N, or K is 1 over T natural log of N, which is 1/4 natural log 570. And if you want, you could plug that into a calculator and get the decimal approximation. I don't think we need to do that every time anymore. Y'all know how to use your calculators, right? If there's something interesting in the decimal, I'll let you know. All right, let's look at radioactive decay. That's modeled by R equals e to the KT. K is the rate of decay. A, find K at 800 years. All right, well, we take natural log of both sides. We have KT is natural log of R, or K is 1 over T natural log of R, which in this case, it's 800 for time and 0.8 for R. This one, I'm going to do it because we need this number for part B. So 0.8 natural log divided by 800 negative 0.00027, not 28. All right, so that's K. Notice it's negative because we're talking about decay. So B, find the half-life of this element. All right, half-life means there's 50% left. That means R is 0.5. So we solve for T here instead of K. All right, find the half-life. We're looking for a time. So the time is going to be 1 over K, natural log of R. If we solve for T instead, we replace K with what we found it to be. 0. Natural log of 0.5. So 0.5 natural log divided by 0.00028 gives me 2,476 years. Pretty long time. All right, 27. Assuming, let's see, at the end of 5 years, an initial investment of 7,000 is now worth 8,000 and some change. Assuming that interest was compounded continuously, what was the rate? Well, we already solved for the rate. It's 1 over t, natural log of a over p. So you plug in 5 for time, and then our amount and our principal, and plug it into your calculator. 28 is exactly the same as 27. So let's look at 29 here. What would you have to invest? So what kind of principal would you need in order to get $10,000 in 5 years at a rate of 2.5% compounded continuously? So A equals PE to RT. We're solving for P here. So P is AE to the negative RT, because we're just dividing both sides by that guy. So we got 10,000 E to the negative 0.025 times 5. Plug that into your calculator and get a decimal. All right, we've already done this 30 here. I remember that one. And we did 31. I remember that one from the quiz too. So we're done with this homework section. All right, page 195. Let's do some more of these. All right, solve. All right, we could take log base 10 of both sides here. So we got x is log base 10 of 30. Over here, let's consolidate our exponential. All right, 100 is 10 squared, so obviously x is 2. And all right, here, let's isolate the exponential again. Take log base 10 of both sides. We get that. Here, it's a log base 10, so let's do 10 to the power of both sides. So x minus 2 is 100, or x is 102. All right, let's do 10 to the power of both sides. 10 to the 0 is just 1. So 3x is 1, or x is 1/3. Okay, this ugly beast here, this is 10 to the 0.2 p. We just multiply those numbers together, right? So p is 6,000 divided by 10 to the 0.2 power. Now it's a weird number, but that's what it is. We could fiddle with it. 6,000 is 6 times 10 to the 3rd. And then 10 to the 0.2 being on the bottom, that would be a negative 0.2. So when you have things like this, you can just add the exponents. 6 times 10 to the 2.8. That's just as awkward as this. So let's stick with that. But there's always things you can do to change the face of the answer. You know, it's representation is what it's called. All right, let's look at these. This one's just like that last one here. 600 divided by 30 is what, 20? 10 to 0.05x. Let's take log base 10 of both sides. So x is log base 10 of 20 over 0.05. Let's best isolate our exponential. What is this? 3 halves? Yeah. 4/3, 4 halves. Yeah. So log base 10 of both sides. So divide by 3. And you have an answer. Let's see. Approximate 2 decimal places. Didn't we do number 9 here in a quiz? Can y'all remember?
Let me see.
I guess we can do it anyways. This is will work.
Looks like we did.
We'll do it one more time here. So, all right, in 2010, there's 1.3 million. In 2013, there's 1.39. What was the growth rate during this period? So we have A equals PE to the RT. We're solving for R. Is 1/T, natural log of A over P. So the time from 2010 to 2013 would be 3 years. And the amount goes from 1.39 million over 1.334 million. And to do part B, we need an answer for part A. So
It was exam 21.
was it?
It was.
0.39 divided by 1.334. The natural log it, divide by 3 is 0.0137. All right, so for B, use that to estimate the population in 2030. In 2030, that's going to be in 20 years. So we start with the 1.334 million e to the 0.0137 times 20. All right. And you can put that in the calculator if you want. Let's estimate when San Antonio will hit 2 million people. If we solve for time, it's 1/R natural log of A over P. We found that R was this number. The amount we want is 2 million. And this one was 1.334 for the principal, right? So this is our P. This is an A. In this case, this is A. All right. So that's how you do that one. We did this annoying phone call one. I remember that one. Certain bacteria population. We did that one. We did the radioactive decay. We'll do these next time. How's about that? So let's end it there. So we just finished with page 195. So next time, page 196. And we'll keep working our way backwards through the book until we knock out all the homework problems. All right, folks, I will see y'all Wednesday.
So we are having class on Wednesday?
Yes, we have class on Wednesday, unfortunately.
Okay. I'll see you Wednesday then, sir.
All right. But we're not having a quiz or an exam. So, you know, if you can't make it, it's not a big deal. You know, I post the videos online. So,
Okay.
all right, y'all.
Okay, thank you.
Have a good one.
Have a great day. Have a good one.
Mm-hmm.